Welcome to
A moment. Ladies and gentlemen, thank you for standing by, and welcome to the Alcanet International TServer High Availability Conference Call. During the presentation, all participants will be in a listen-only mode. Afterwards, we will conduct a question-and-answer session. If you have a question, please press the 1 followed by the 4 on your telephone. At that time, your line will briefly be accessed from conference to obtain information. If at any time during the conference you need to reach an operator, press *0. I would now like to turn the conference over to Andrei Lebedenko, Staff Support Engineer, EMEA. Please go ahead, sir.
Hello, everybody. Thank you for joining. Let me introduce Sally Ann Taylor, who will be assisting during this webinar session by answering your chat questions. She is a Senior Support Engineer from EMEA region. So, today's subject is TServer high availability. During this session, we will be discussing high availability of TServer in general. We will see some examples of configuration. We will see how TServers communicate to each other, and some troubleshooting, and also there will be question and answer section. So, the agenda for today's webinar is TServer high availability overview, which is main name for warm standby and hot standby, licensing questions, HA proxy, keep alive protocol between TServers and also between TServer and HA proxy, and primary to backup TServer communications. Also, we will discuss information in backup TServer memory, what it represents, what is the source of information is, and how long it remains in the memory. The switchover procedure will also be discussed as a procedure from SCS, as from management layer, and also what may happen in case of emergency. There will be also troubleshooting section when we will touch configuration issues and network outage issues as well. And we begin with the TServer high availability overview. The main aims, main goals of TServer high availability overview, of course, are to eliminate single point of failure, to reduce possibility of downtime in a call center, and to extend the flexibility for maintenance, so-called rope upgrade, which was recently introduced for some TServers starting from version 7.5. Okay. Right, so currently for TServer we have two high availability modes. One standby, which offers the ready backup TServer application to switch into the primary mode, And this doesn't provide full synchronization of call and DN data between primary and backup TServer. But, on the other hand, it keeps the load on a backup TServer at low level. The hot standby, in addition to features provided in warm standby, the backup TServer also keeps all information about DNs and calls synchronized with primary TServer. Of course, it puts additional load on backup TServer and on backup hardware as well. So let's talk about warm standby. In the warm standby configuration, the backup TServer remains initialized and ready to take over the operations of the primary server. Warm standby configuration reduces to minimum the inability to process interactions that may have originated during the time it took to detect the failure. It eliminates the need to bring a standby server online, thereby increasing solution availability. So, backup TServer does not process any client requests in the warm standby mode until the management layer changes its role to primary. And during startup, the backup TServer executes these steps, which are reading the CME configuration, connecting to management layer, connecting to license manager, of course, initialize internal structures, internal tables for DN calls, clients, etc. It connects to the CTI link or HA proxy, and it reports the status to management layer as application status running. After that, it broadcasts to all connected servers message ICC event link connected. So basically, in a warm standby mode, backup TServer initializes entirely as it starts up normally. In warm standby mode, on switchover, the following will happen. The client applications will reconnect to new primary TServer. The new primary former backup TServer will start processing all new requests for service. Because there is no connection between TServer primary and TServer backup, only new requests will be processed. Although normal operations are restored as soon as backup process take over, the fault management effort continues, and that effort consists of repeating attempts to restart the process that failed. Once successfully restarted, the process is assigned the backup role. It means that it will not be switched to primary until the further notice from the management layer. So if we put it as a diagram, we will have this something like this. So that in this particular case, we've got diagram with the link, which, as you can see, accept two connections, one connection from the primary and another connection from the backup. However, this connection from backup is just a ready connection to become really active connection. And obviously the switch between modes from primary to backup performed purely and solidly by solution control server. So let's have a look at what we've got for hot standby and what the difference is. In hot standby, backup TServer is still fully initialized. Clients connected to both the primary and to backup server at startup. However, backup TServer sends only link status and connect confirmation to its client. Backup server data is synchronized from the primary TServer. So obviously there must be a link between primary and backup TServer. Although for the 7.1, most of TServer support hot standby, for which the documentation appears in its deployment guide, there is one exception, which is IVR server, and this does not support this feature yet. And again, startup procedure for hot standby TServer is pretty much the same as for warm standby. However, TServer will receive disconnect client requests, but will not send any information messages to those clients until management layer changes its role to primary. So again, backup TServer, during startup procedure, will execute the following actions. Read information from CME, connect the management layer, opens connection to its license manager, initialize internal structures, DM calls, etc. Connect to CTI link, and now, as you can see, there is additional step, which means connect to primary TServer. After that, it will report application status running to management layer and broadcast to all connected servers message ICC event link connected. Again, if we put it as a diagram, we will see slightly different diagram here. So, additional connection introduced here as between primary and backup, and also additional connection here for clients. So, if we will have a look on CME configuration for primary TServer in hot standby, the picture will be like this. You need to specify backup server name and redundancy type. The redundancy type specified in primary TServer options in CME. This information then copy it over to backup TServer. So you will see that redundancy type field automatically populated for your backup TServer. So there is no information in backup server field in a backup TServer configuration. It is not necessary because the link established in CME configuration for primary. In version 7.5, Genesis provided support of rolled upgrade feature for UK framework and some other TServers, and this feature provides additional flexibility for those call centers which cannot be stopped even for upgrade of TServers. The main idea is to synchronize internal structures between two TServers, then bring one TServer down, upgrade it, start, switch the roles, bring down another TServer, upgrade it, and start as normal. However, there is one small problem, because during the synchronization, new calls will appear in the primary TServer, and those calls need to be transferred over to the backup TServer. Without this, primary TServer should not be stopped. So the procedure is as following. Backup TServer stopped, backup TServer upgraded, and backup TServer started. The TServer roles switched from primary to backup, and originally primary TServer stopped, originally primary TServer upgraded, and originally primary TServer brought again as a running application, but this time in backup mode. Since this moment, both TServers are upgraded and working in HA as configured. This step, however, requires additional functionality which was introduced in 7.5. Not for all TServers though. This is option called HA sync DLY LNK con. By default, it's disabled. The fragment from documentation said that it determines whether the backup TServer delays sending event link connected until it has been notified that TServer synchronization has completed. With value true, the backup TServer sends event link connected once it has completed with synchronization after all calls are cleared in the TServer primary memory. With value false, there is no delay in sending event link connected, and synchronization takes place as in 7.1 and previous TServers. And these changes take effect if TServer restarted. Why it's vital in rolled upgrade? Let me go one step back. During time interval between this step and this step, obviously few calls will be collected by primary TServer only. There will be simply no backup TServer in the call center. After backup TServer will be started, even in high availability mode, there will be no synchronization, no update about calls which were collected previously when there was no backup TServer. So backup TServer must wait until all those calls are gone, and only newly collected calls synchronize it fully between primary and backup TServer. Only after that, we can be absolutely sure that all calls are synchronized. So we can bring the TServer, primary TServer down, or switch the role, which is in this case the same. This feature originally was introduced in 7.2, but fully tested and fully operational in UK framework and some similar TServers only starting 7.5. So let's go discuss licensing. When TServer operating in a hot standby redundancy mode, it requires a special CTI HA technical license, which allows high availability implementation, and this license needs to be in addition to the regular TServer licenses. If there is no such license available, neither on TServer will start if they configure it as HA proxy, HA pair. And both TServers, primary and backup, must use the same license to control the same pool of DMs. If your TServers are configured with the hot standby redundancy type, or the license for CTI HA support. So, from FlexiLAN perspective, both TServers, primary and backup, appear as a single application. They manage the pooled technical and seat licenses internally. Because of that, both TServers can use configuration option in session license set to maximum. The HA proxy is an application which set times required to configure high availability for TServers. And main idea of HA proxy is to be an application which connects to the CTI link and works as a server to which TServers connect, both TServers primary and backup. And it sends CTI messages to those TServers and receive messages requests from those TServers as well. It can accept second connection from a backup TServer working in hot standby mode, even if CTI link doesn't allow such a connection directly. Some TServers in PBX's configuration still require HA proxy to work in hot standby. This is due to the fact that some CTI links do not allow more than one connection per link per time. So, the same diagram as we saw before, but with high availability TServer proxy. And it sits between link and primary and backup. This diagram is for hot standby, which is often used by our customers but you also can imagine this for one standby as well. So this protocol between HA proxy and link is a proprietary protocol for this particular link. And this also the same protocol between primary TServer and HA proxy. However, as you can see in this case, there is additional point of failure introduced in the way of HA proxy. What will happen if this HA proxy fails? This is probably not something our customer would like to have. So it is possible to configure two HA proxies, primary and backup. In this case, the diagram will look like this. This diagram, though, simplifies these things a little bit. For example, there is no link between SCS and any HA proxy. In reality, there is a link to start this process. However, we need, well, start and stop, obviously, but not to switch the process over, not to switch a role. The way how it works is the following. The presence of HA proxy in your implementation doesn't change the failover scenario of a TServers. So it's the same way as in a normal without HA proxy implementation. However, when a HA proxy fails, it is TServer who coordinates the switch to the backup HA proxy, if configured. In this case, the primary TServer sends a command to the hot standby HA proxy to switch it to primary mode. Also, the management layer can start up and shut down an HA proxy. It does not control HA proxy mode. That control is left to a TServer in a primary mode. So, to keep solutions stable, we need some sort of keep alive protocol between certain parts, between TServers, HA proxies, and this section is about keep alive protocol. Let's have a look. To configure ADDP, which is normal Genesis keep alive protocol these days, between primary TServer and backup, you can go to CME and to a specific section called backup sync, and there are a set of options by default switched off. So timeouts here as normal for ADDP local and remote response, and ADDP trace default off can be switched on or to value both, which pretty much the same as you configure when you connect one server to another in CME. So if everything correctly configured, after startup and connect between two TServers This, of course, related only to hot standby when you've got connection between two TServers. There will be messages like this when TServer connected, initialization started locally, remotely, and then you've got ADDP pings. If connection between two TServer lost, they will reconnect, try to reconnect to each other according to value of option sync reconnect timeout, this option. By default, it's 20 seconds. So, however, ADDP protocol is not supported for connection between TServer and HA proxy. Instead, a switch vendor proprietary protocol is used to ensure that connection is stable. For relevant configuration parameters, please refer to Part 2 of Deployment Guide for the relevant TServer. The primary to backup communication in hot standby mode, of course. In order to ensure that there is no loss of any call or DN related data, the primary TServer sends special messages to the backup TServer to synchronize internal structures of both applications. It happens when activity received via CTI link or request received from the T-library client. Let's have a look on example which will describe the situation maybe best. So this is primary TServer message. When call created, you will see this kind of prefix, B sync, and message sent to backup TServer. This message will include all attributes, including ICC attributes, if any. On the receiving side, on the backup TServer, you will see this exactly the same message, again with a vsync and the same set of attributes. Another example is when backup TServer received message from the CTI link and created connection ID. As you know, connection ID is unique for each TServer, and backup TServer is not an exception. And because it's different application comparing to primary, the connection ID will also be different. In order to keep everything in sync, this connection ID needs to be changed. So, key steps in this case are, after call actually created in backup TServer mode, and synchronization packet received, like this, there will be message in backup TServer log saying that high availability section requested change of connection ID from one which was created originally to one which was received from the primary TServer. And then you will see ICC message saying that connection ID changed. This is how it works. This is normal. That's what you should see in the TServer logs. This is very, very important. And let's have a look how it looks like, how it works in dynamic. So we've got call which arrives on a PBX, and PBX reports it via link to the primary TServer and simultaneously to the backup TServer. At the backup TServer, we've got different connection ID. Primary TServer, this moment reports new call arrived to clients, and there may be some communication from the clients for this connection ID. In order to keep everything in sync, primary will send information packet to backup. This is how it should work when everything is fine. And obviously when clients then will send request update user data back to primary, information will be updated again from primary to backup. What will happen if, for whatever reason, the connection between primary and backup will be broken? There is no step 5. In this case, communication between clients and primary TServer will be maintained without any problem as it was, but information about the calls in the primary TServer memory will not be synchronized with the backup. Even connection IDs may be different. And when communication will be restored, there will be no synchronization between primary and TServer, primary TServer and backup TServer. So everything what happened during this outage of network will be in place how it was. So if, let's say, during this outage there was a call arrived on the primary and backup is not aware about it, then if you switch the role, the messages from the client will not be understood by TServer about this call because it simply has no such connection ID. It wasn't synchronized at this step. This is very important to remember. Okay, another example. This is not call-related. This is agent-related step. And as you can see, again, the same prefix in a log, bsync, send to backup. TServer name as it configured in CME, and information, complete information about attribute DN, and all the related attributes as well. This is agent goes ready, if I'm not mistaken. And on the receiving side, the same attributes received and information in internal tables updated. So let's have a look what information backup TServer keeps in its memory. Obviously, we will be talking about hot standby only. In this mode, backup TServer received the following information from the primary. Call status, from the CTI link, of course. Call status, DM status, and some requests. And from primary TServer, it receives also information about connection IDs with all T-library attributes, including ICC data, and if there is configuration for emulated agents, then for emulated agents as well. So TServer primary and TServer backup in hot standby mode pretty much synchronized to switch the roles. This synchronization takes approximately a few milliseconds. So probability to lost information during switchover is very, very low. Any call-related information remains in the backup TServer memory until the call is treated as finished. The mechanism is the same for backup as a primary, and what's important, it works independently. And this also true for stack call cleanup function, and it's very important to keep in sync all configuration options in CME for both TServers regarding call cleanup function. The current implementation of hot standby, actually any standby mode in Genesis, doesn't synchronize any option from the options tab in the CME from primary to backup. It is your responsibility to keep them in sync. So, switchover procedure. Normal switchover procedure from SCS, normal I mean when we've got connection from SCS, from SCS to TServers, both of them, is the following, and it's basically a message, specific message from SCS to LCA connected to specific TServer to switch its role. And it may be triggered either manually via solution control interface, also may be switched from the script. For example, there is a good example because CTI link disconnect is not a reason to switch the role. However, you can create a script which will be fired on receiving such a message and switch role of the TServer with problem. And obviously, if one of TServers, I mean primary TServer, goes down, the backup will be switched to primary. If the TServer backup loses its connection to the primary TServer and there is no connection to the management layer, for example, solution control server down, network failure, etc., the TServer will not change its role. It's important to remember that it's a solution control server, management layer actually, role to switch the primary to backup or vice versa. And that there is a good reason behind it is we should keep only one TServer as a primary in the call center, and if solution was working before outage, it's was to assume that at least one TServer was in primary mode. If solution wasn't started and starts during the outage of network or when management layer is unavailable, both TServer will be started as a backup TServers. And only after that, one of them will be switched to primary, again by command from management layer. So let's have a look on the troubleshooting, what kind of common issues can be observed in high availability of TServers. First of all, configuration issues. As I said, it is very important to remember that both primary and backup TServer are independent in terms of CME options. Configuration server does not synchronize either options or their values in different TServer applications objects. If you change a value in one TServer configuration, you must change it in another. However, there are obviously some options which normally differ in primary and backup CME configuration. These options related to CTI link connection and log options. We normally recommend to keep logs in different folders. So when TServer configured to support either warm or standby hot standby mode, it is vital to remember that when at least one TServer is running, you should not change redundancy mode or host or port in any TServer configuration, primary or backup. If both TServers are running, do not remove the backup TServer application object from the configuration, from the database. And that was regarding configuration. Common issues. The common issues regarding network, and in this case between primary TServer and backup TServer, in case of high availability, hot standby. If the link between primary and backup TServer is disrupted, an update for the call and the unrelated data will not be possible, obviously. However, both TServer will try to reconnect according to value of sync reconnect timeout. Default value is 20 seconds. So you will see messages attempt to reconnect and then TServer name in a log file. Upon reconnect, there may be a gap in the calls which were created during the period of disconnect. Such calls cannot be processed by backup TServer due to the fact that connection ID wasn't synchronized if you switch the role of backup TServer to primary. what kind of symptoms may be observed in this case? If you switch the backup TServer to primary in this case, you may see invalid connection ID error, which will be reported back to clients on request of update user data, perform any changes to the call, anything. If there is no switchover between primary and backup, and everything works fine, but you may see in the log file that there is no synchronization messages for those calls from primary to backup. The network outage between TServer and solution control server also may happen. In this case, if TServer lost connection to solution control server, it will not change its role regardless of whether it was primary or backup. It is important to remember that connection between primary and backup TServer does not provide switchover functionality. So even if there is a stable connection between primary and backup, they will not control each other's role. It is solution control server functionality. There will be no message in TServer log if or when solution control server stops or disconnects. And the symptoms in this case may be that both TServers run as backup right after startup, or client can't connect to any TServers. Solution doesn't work, however there are no alarms generated in solution control server. So this is basically common issues for network problems in TServer high availability, and this brings us to the end of this section. So other resources for information: we recommend to visit our website, where you can find additional training courses in our university. And of course, information which we publish on our knowledge base, which includes latest information as advisories, release notes and information, product manuals, and white papers. Technical support solution search archive consists of from over 3,000 service request solutions, and weekly notification about new or updated product advisories and release notes. We currently have no information about further technical tutorials, and however you can find them on our website when they will be announced. Thank you very much, ladies and gentlemen, for your time. Any questions, please?
Ladies and gentlemen, if you'd like to register a question, please press the 1 followed by the 4 on your telephone. You will hear a 3-tone prompt to acknowledge your request. Your line will then briefly be accessed from conference to obtain information. If your question has been answered and you would like to withdraw your registration, please press the star followed by the 0. If you're using a speakerphone, please lift your handset before entering your request. One moment, please, for our first question. Our first question comes from the line of Mark Robinson. Please go ahead, sir.
Hello?
Hello?
Mr. Robinson, please go ahead. Your line is open.
Yeah, I did ask. Can you hear me now?
Yes, sir. Please go ahead.
Will these slides be available? Will you email them to us?
I think so. I think there will be URL which we can use to download this information.
If you go in a few days, about Thursday or Friday, they will be available with recording on tech support website under tech tutorials, so you can
Okay.
check it.
Ladies and gentlemen, again, as a reminder, to register a question, please press the 1 followed by the 4 on your telephone. Our first question comes from the line of D. Shaw. Please go ahead with your question.
This is Kayur Shah here. My question is, when we, are you guys able to hear me?
Yes?
Okay, my question is, when we stop the backup and restart it while upgrading the TServers, we restart the backup. After that, we switch over from primary to backup and backup to primary. Now, during that time when if some calls came in on the primary server, they would be lost. So should we wait for some time, say 10 or 15 minutes, for all the calls on the primary to go and then switch over?
Yes, this basically is main idea of this rolled upgrade. Let me maybe go back to the slides and yes, so there is an option for some TServers which control this mechanism, so you can do it automatically. This option enables the internal timers for each calls which were collected during the period when only one TServer was running, only primary. And when those calls will be finished, because there is no synchronization between primary and the backup upon restart, but only during the runtime, when those calls which are unique for primary only will be finished, then backup TServer will send a message event link connected, and obviously will send the application status running to the management layer. So only after this moment you will be able to switch the role, and this will be safe to switch.
Okay, so the backup TServer will not show as started until all the calls are finished. Is that correct? Okay, thank you.
Our next question comes from the line of Prad Paskara. Please proceed with your question.
We actually have a scenario where there is 2 links from the switch, one to the primary TServer and one to the backup TServer. Now, what would happen in a scenario where, for whatever reason, new call message is just sent across the link from the switch to the backup TServer? Will the backup TServer synchronize this call with the primary, and then the primary send it on to the TServer clients?
No, unfortunately not. We rely on information from CTI for both TServers.
Okay, so it's only the primary TServer. If it gets the message, it will be synchronized. It won't be the other way around.
Correct.
Ladies and gentlemen, as a reminder, if you'd like to register a question, please press the 1 followed by the 4 on your telephone. Our next question is a follow-up question from the line of Mark Robinson. Please proceed with your question.
Earlier when you mentioned the rolled upgrade, you said it was for the UK and some other. I would like to know whether it applies to us.
Right.
What are those others?
UK framework TServers. It's a set of TServers based on a specific functionality introduced in 7.1, I believe, and also some TServers which were introduced later on in UK but do not incorporate this functionality. For example, Alcatel A4400. You can find this option in documentation for this Alcatel TServer as well. For other TServers, for example, for Avaya, I believe it may be introduced later, but I can't give you any time frame for it.
Okay, so look in the documentation, and Avaya may not be available yet, right?
Yeah, that's correct.
Okay.
Our next question is a follow-up question from the line of Mr. Deshaw. Please proceed with your question.
It's not a follow-up, it's a different question I have. You said if the management layer is not working, then both the TServers will start in the backup mode.
That's correct.
What do we have to do to make one of the TServers primary, say in case we are troubleshooting or something, in case of an outage?
Okay, in this case I would recommend to temporarily disable the high availability for that TServer in CME. So stop both TServers, switch it high availability to non-specified, and obviously remove the backup TServer from the configuration.
And to stop the high availability, you go to the options, the TServer?
Yes, let me show you on a slide. It is here.
Okay.
So this option and this option should be taken away.
Okay, thank you.
Mr. Lebedenko, there are no further questions at this time.
Thank you very much, ladies and gentlemen. Thank you for your time. Thank you and goodbye.
Ladies and gentlemen, that does conclude the conference call for today. We thank you for your participation and ask that you please disconnect your line.